folks, let's go ahead and start to take a look at 7 and 8. So we're starting to complicate our denominators a little bit. And I want to point out that if I were to factor the GCF out of this denominator, right, this is v times v minus 5, right? Same here, v minus 5. And this is just a v. So when I think about building my LCD, right, if I look at it, I have a factor of v in a couple of these. Actually, all three of these have a v in them. And then I have a v minus 5. So in my LCD, I need a v and a v minus 5. And then we want to take the highest exponent we see of each of those factors. So the v's all have the 1s, right? And then the v minus 5 is also raised to the 1. So this is going to build my LCD. Where over here, right, I have m minus 1, another m, and then m minus 1. So when I go to build my LCD, I need the m and I need the m minus 1. And then we want to take the highest exponent of each of those factors that we saw. But the highest exponent, again, if you look at m, it was m to the 1, m to the 1, m to the 1. So m to the 1 here. M minus 1 to the 1, there was none here. M minus 1 to the 1, so 1. So those are ultimately going to be my LCDs. Now I'm going to erase the little breakdown I just did, and I'm only doing that because I have so little room to write these solutions up. But what I'm going to do, just like all the previous examples, I'm going to multiply each fraction by that LCD, and it should knock out the fractions. So let's go ahead and multiply, and I'm going to write small here, v minus 5 to 1 over v, right? And then v minus 5 to 3v plus 12, and I'm going to write this as v minus 5 on the denominator. That should be equal to v times v minus 5 times 7v minus 56 over v minus 5. All right, so I'm going to take that LCD, multiply it to every term in that rational equation, and then a bunch of stuff will cancel. Keeping in mind, oops, I can hear my heater coming on. So keeping in mind that we've got these parentheses that are protecting our binomials, okay? So I want to apologize if my heater is about to come on and be a little bit noisy on this video. I will do my best to turn it off. I'm recording this when it's pretty cold outside. Okay, so where I'm going with this is I'm going to cancel the v's, right? I'm going to cancel the v's here and the v minus 5s, the v's here, and again the v minus 5s, right? So I've got all of that canceled out. All of my fractions go away. And then we're just going to see what's left over. All right, so here I have a v minus 5 left over, right? And then if I look at my second fraction, I'm just going to have the 3v plus 12. Okay. And then if I look on the other side of that equal sign, I'm going to have 7v minus 56. So while those things had, or while all of those things by those binomials had those protected parentheses, I ultimately didn't need to really worry about it because these entire denominators cancel, which is fine. Okay, so as we're moving through this, all right, I'm going to collect like terms. So on this side, I got 3v plus v, so I have 4v, right? And then if I look at my numbers, I have negative 5 plus 12, so that's going to be positive 7. And then I have 7v minus 56. So I'm going to go ahead and subtract 4v from both sides. And I'm going to at the same time add 56 to both sides because I have a linear equation. So let's see what we get. These are going to cancel. 7 plus 56 is going to give me 63. And these will cancel. 7v minus 4v is going to give me 3v. So let me go ahead and divide both sides by 3. And that's going to give me v equaling 21. And that's a legitimate answer because if I were to plug 21 into any of my denominators, it would zero out. So I'm going to keep this answer, okay? All right, so then let's take a look at number 8. Same idea, right? And we know our LCD. So I'm going to multiply every fraction by this LCD and see what cancels. So I'm going to do m minus 1 to 1 over m minus 1. All right, because if I factor out the GCF here, it is m times m minus 1. All right, then we're going to do m minus 1 to 1 over m. All right, and then we're going to have m minus 1 to 5 over m m minus 1. All right, so let's see what cancels. The m's will cancel here. The m minus 1's will cancel. The m will cancel here. I'm going to have an m minus 1 left over. The m's will cancel here. M minus 1's will cancel, and I'll have a 5 left over. So if I'm starting to build this, it looks like I have 1 plus m minus 1, and that should be equal to 5. So let's go collect some like terms. 1 minus 1 is going to cancel. That's nice. This actually just leaves me with m equaling 5. And if I think about what would zero out my denominator, if I got an answer of m equaling 0 or m equaling 1, that would be an issue. But m equals 5, totally legit. I can put those into my denominators and they won't zero out. And I've solved that problem. All right, thanks so much. Bye.